All right, you guys, we're back. I'm going to recommend you watch these videos in order because it's going to be a constant evolution as we go here with what I'm showing, because I will review what I put out and then I will want to make it better as we move along. So with that said, I want to do a quick video on fusing because it's such a complicated topic. And I'm learning with you guys as I go, and I'm setting this up, and now I'm starting to see what some of the more experienced guys that have big systems and clipping stuff in and out. Like I said in the last video about this is my Larry trailer right here, how I have it wired. Again, I only ever looked at that circuit when I was building it like this with one battery. I never really zoomed back and saw what that circuit looked like with another battery in there. And eventually I'm going to want some more batteries. And it just makes sense that there not be a battery in there or a fuse in there, I'm sorry. And the Ohm's law is why. If you have a solar system and you want to clip things in and out, due to this, amps increase, volts stay the same. Okay, now I have a 150 amp fuse in here. If I split it between two, I would only need a 70 amp. So the minute you unplug one of these batteries, your Ohm's law goes to hell. You don't need a fuse in there. And we're going to get to why shortly. I'm a 30-year industry guy, big equipment, $3 million machines, automation, all that. I'm used to seeing a cabinet full of fuses for every output component on the machine. But I've kind of evaluated a solar system a little more. And again, these have fuses in them, just like the guys that have been down this road for a long time tell us. But the actual work of a solar system, it isn't the inputs, it isn't the outputs, right? Like they're doing work, but the actual work of a solar system is to move power from the sun through your bars into your battery and then move that power back out to the output device, right? So the actual work of this machine, and I'm an industry guy, I'm a machine guy. I need to know how the machine works, eats, sleeps, breathes. So the object of the solar system is to pass that power cleanly through, right? And while I'm programmed as a 30-year guy and seeing a fuse on every device, everywhere in the cabinet, like I'm programmed to fuse. And I'll stand on if you got one battery, you want to stick a fuse in that battery line, you're perfectly fine, as I showed in the first few videos. But moving forward now, we're building bigger systems. We're clipping in more batteries. We're going to need to be able to clip and unclip these batteries in and out, and that's going to change our amps. So you can't have a fuse in there. Okay, so with that being said, let's think of a train, right? Like you have a train is to move big goods, the heaviest stuff you need to move it on a train. Well, what's a train? Has tracks. There's no 90-degree turns in a track. So let's take a look at a fuse with some power running through it and what it actually looks like. And honestly, it's a great visual, and why the guys are always promoting put straight wires in there, like you're just causing problems. So if we have a fuse in the wire and we think of the wire, like Todd always says, like plumbing, right? Like we're running power through that fuse. It's no problem at 40 amps. Like it's just cooking along. Like that's a light load for the train, right? But when we crank this sucker up, when you start stuffing 200 amps in there, now look at what happens when that wire is blasting full of power. Now you're making it turn, right? And the train don't like to turn. There's a lot of weight on there, a lot of goods, a lot of power, right? And that creates the heat. So that's the argument of to fuse or not to fuse. A straight wire isn't going to have that obstruction in there. So you can kind of see in your head a little bit, because I'm all about the visuals. The good and the bad with the fuses. Again, I'm an industry guy. We fuse everything, but boy, the more I start mocking up, the bigger the system gets. The more I'm on board with the guys, and I appreciate the learning as well, right? Like I want to pass that down to you guys. So I think that's going to be it for my fuse update. I'm not telling you to fuse or not to fuse. I'm trying to give you all the information so you can make your own decisions and buy your own parts and feel comfortable when you're done. But I'm definitely in the boat that I would not be putting fuses in those batteries there, just because the clip in, clip out part changes all our Ohm's law, and that wouldn't make sense. Like you wouldn't do that. Plus we want to keep our train tracks clean. and you want to be able to distribute that power clean with the least amount of obstructions. So again, the work of the solar system is to move that power in, move it in from the solar, blast it through there smoothly into your batteries without making any heat. And then when you need it later on at night, blast it back out through that inverter and use it up without any 90, the least amount of turns in the train tracks is going to allow that to happen the most efficiently. So on that note, that's all I'm going with on fuses. Make your own choices, and have a great day. Bye-bye.